Hello, this is going to be Chapter 5 review. Hopefully you have already attempted these questions on your own. If not, no worries. You can pause this and do each question, and then after you finish, check your answer. Or if you are stuck on a few, you can go ahead and just skip towards that question to check them. So let's focus on number 1 first. Rita's hiking along a trail that is 13 7/10 miles long. So far she has hiked along 1/10 of the trail. How far has Rita hiked? So our numbers are, the total trail is this long, 13 7/10, and she has hiked 1/10 of it. And they want to know how far she has hiked. Well, the first thing that I would do is I would turn 1/10 into a decimal. So I would rewrite it like that, and now I have numbers and numbers to look at. This is actually from our Chapter 4, multiplying decimals, because in order to get our answer, we're going to need to multiply 13 7/10 times 1/10. And this reminds me of in our last chapter when we talked about recognizing patterns. When we look at patterns, this is going to have us move the decimal point in certain ways. So if our decimal point is right here, if we multiply by a decimal, right? If our decimal point is right here, we're going to move it over 1 spot. And then for this one, we would move it over 2 spots. So 1 position, 2. If we were doing this, we would move it over 3, and we would need to add a 0. So for this one is the one we're thinking about. So Rita has hiked 1 37/100 of a mile. All right, let's look at number 2. Use the numbers on the tiles to write the value of each expression. These are all expressions. You can use a tile more than once or not at all. Well, if our exponent is 0, this is the exact same as our patterns. These exponents, or not having an exponent, is going to give us a pattern. So 0 as an exponent, our decimal does not move. So our answer is going to be 35 5/10. We have a 3 and a 5. We can use them more than once. We're good. Now, when we divide by 10, we need to move our decimal place 1 spot to the left. So this 10 tells us to move to the left 1 spot. So then our answer would be 3 55/100. Still works with our tiles that we have. And then lastly, our exponent is going to tell us where our decimal place is going to move. So exponent of 2 says that we need to move to the left 2 spots. So starting in our original position, we need to go 1, 2, and end here. So our answer is going to be 3. Biscuit, no. So we use this more than once, and we are good. So we have 355 thousandths. Number 3. Tom and his brothers caught 100 fish on a week-long fishing trip. The total weight of the fish was 235 pounds. So 100 fish and the total 235 pounds. Write an expression that will find the weight of one fish. Assume that the weight of each fish is the same. So they caught identical fish. Maybe they're all twins or something. We will use these two numbers to write an expression. Well, we have encountered that word before, right here, expression. So we need to write something that resembles this. So we're going to have a operation symbol, and since we are doing division, it's going to be a division symbol. And our expression needs to say, needs to tell us how much one fish would weigh if we had 235 pounds of fish and we had 100 of those fish. We don't need to put an equal sign for this expression. Now they actually want us to solve it. So what is the weight of one fish? Well, the weight of one fish is from this expression. So let's look and see how to set this up. Now what I would do is, since we have our powers of 10, 100, right? A power of 10, I would just use those those division patterns that we talked about. So in one of our chapters, or one of our lessons, we had this pattern that we would fill out. If they don't give you a decimal, for example, 235, the decimal is always after the last digit. If it's not actually written, you can just know that it's hidden and it's just right there. It's just invisible. So when we divide by 1, obviously we get the same number. When we divide by 10, now this 0 is going to give us a clue. So this 0 tells us that we're going to move one position to the left. So our decimal starts here. We're actually going to move over one spot. So now our number is going to be 23 and 5/10. Now 2 zeros tells us that we need to move 2 spots to the left. So putting our invisible decimal there, now we're going to move 2 spots to the left. And now our answer would be 2 35 hundredths. So one fish, right, divided by 100, 235 pounds divided by 100 fish, each fish would be 2 35 hundredths pounds. Suppose the total weight of the fish caught stayed the same, but instead of 100 fish caught during the weekend, only 10 fish were caught. How would the weight of each fish change? Explain. Well, if you had 100 fish with 235 pounds and then you went down to 10 fish still with 235 pounds, well, that makes me think those are just really big fish. So I would write the weight of each fish would increase. And we actually already did all of this work because we already divided that 235 pounds divided by only 10 fish. So our answer would be each fish would weigh 23 and 5/10 pounds. Big fish. That's a big fish, I think. I don't know. I don't fish, but seems big. 23 pounds? All right. Let's skip to number 4. Draw a model to show 5 and 5/10 divided by 5. All right, so we need to draw a model. That's what they're asking us to do. And these are our numbers that we need to use. So first off, what I would do is I would set up my number of groups. So my divisor, which is going to be my second number when it's written like this, is going to tell me how many groups. So what you could actually even do is maybe just make 5 circles. 1, 2, 3, 4, 5. Sorry, went outside the lines. And now what I'm going to do is I'm going to draw my dividend, which is my number that I'm dividing up. So these squares or rectangles, imperfect squares, they represent one whole, right? And then my 5/10, I just make those by tally marks. So this is a 1, not a 10th. What I also noticed about this problem is that in my ones place, I have a 5, and in my tenths place, I have a 5, and I have 5 groups. So this is actually going to make it pretty easy, because what I can see is that I have an equal number of ones and tenths. So I could give this to group 1, give this to group 2, give this to group 3, give that to group 4, and give this to my final group. And then when I'm done, I could make sure, or I could count, I know I have 1 and 1/10. So 5 and 5/10 divided by 10, or divided by 5 equals 1 and 1/10. Emma, Brandy, and Damien will cut a rope that is 29 and 8/10 feet long into 3 jump ropes. Each of the 3 jump ropes will be the same length. Write a division sentence using compatible numbers to estimate the length of each rope. So write a division sentence using compatible numbers to estimate the length of each rope. All compatible numbers are numbers that make sense to you and that are easily divided or multiplied or whatever operation you're doing in your head. That's all they're asking you to do. So what I would do is I would look at our 2 numbers that they gave us, so 29 and 8/10, and then also 3, and I would think about what could I change to make them a little bit easier to work with in my head. Well, I see 29 and 8/10, that's really close to 30. And since I already have a 3, since I already have a 3, I'm not going to move or change 3 around because 30 and 3 go pretty easily together. So I would say then if I have about 30 feet of jump ropes and I want to divide them into 3 equal sized ropes, that each rope would be about 10 feet long. Now if you, let's say, rounded 29 and 8/10 to maybe 27 feet, which is totally fine. You could also keep your 3, you would keep your 3 jump rope length, or 3 total jump ropes, and then each one would be about 9 feet because 27 divided by 3 equals 9. And that's close enough to 10. So that would also be a reasonable estimate. The thing with estimates is if it makes sense to you and you can justify it, then it is a correct estimate.